Now let us see the reactions of aliphatic amines. Now the first type of reaction is called alkylation. That happens with the alkyl halide. Alkyl halide is generally represented as RCl. So for example, methyl chloride, then an amine, a primary amine, RNS2 can be CH3NS2. A molecule of H and HCl, H here and Cl here combined. And NH portion gets connected to R. Now it's a nucleophilic substitution where the nucleophile is the amine. Now the lone pair is donated towards this R group, and Cl is simultaneously removed as Cl negative. Here also nucleophilic substitution reaction occurs. Cl is removed. Then we get the corresponding alkylated amine in both cases. Now acylation with the acid chlorides. Acid chlorides are derivatives of acids. On reaction with BCl5, we get COCl group, and RCOCl represents an acid chloride. But the chlorine atom combines with H here, HCl is removed, and the NH portion gets connected to the C of CO group. So we get RNHCOR. CONH2 group is an amide group, and here we get a substituted amide. A secondary amine also can react with the RCOCl. HCl is removed, and then COR is connected to N. COR is connected to N. Again, that is a nucleophilic substitution reaction. The lone pair of nitrogen being given to the carbonyl carbon, ionization of carbonyl carbon to maintain the valency of carbon equal to 4. Then the lone pair of oxygen comes back so as to form a double bond here. Then to maintain the valency, Cl is removed as Cl negative. And then when lone pair is donated, N carries a positive charge. Then H positive is removed, RCONH, R is formed. So that is the simple mechanism for acylation reaction. Acylation also can occur with the acid anhydride, again a nucleophilic reaction. The lone pair of nitrogen is given to the carbonyl carbon, ionization occurs like here. We get NS2 positive group connected to carbonyl carbon, O minus, OCOCH3. Now here the OCOCH3 group acts as the leaving group, so that when this electron pair goes as a bond pair, here OCOCH3 negative is removed. And that is CH3COO negative will combine with H positive here, and we get CH3COOH and CH3NHCOCH3. Tertiary amines do not react with the acid chloride or acid anhydride due to the absence of an NS bond. Now next is carbylamine reaction given by aliphatic and aromatic primary amines only. Now this is a test for a primary amine and also a test for chloroform. We have studied it in the case of alkyl halides. Now heat to boil 1 ml alcoholic AOH, 5 drops of chloroform and 2 drops of or a pinch of. If it is a solid, a pinch of. If it is a liquid, 2 drops of the substance primary amine are boiled. An offensive smelling gas is produced. The offensive smell is characteristic of isocyanides, R and C. R bond and C, that is isocyanide. Then alcoholic AH neutralizes the HCl produced during the reaction. Now RNS2 contain 2 H atoms, CHCl3 contain 1 H atoms. So total number of 3 H atoms combined with the 3 chlorine atoms, removing 3 HCl absorbed by alcoholic AH, and the remaining part Rn and C will give isocyanide. And all isocyanides have this offensive smell, and that is a characteristic test for primary amine as well as chloroform. Now, an important reaction, that is reaction with nitrous acid HNO2. It is written as HON double bond O. Now, it is prepared inside the reaction medium by the reaction between sodium nitrite and hydrochloric acid. The temperature range is given 273 to 278 Kelvin, nearly room temperature. Now, this nitrous acid dissociates into OH, N and O. Now the primary amine may be split into CH2, N and H2. So 3 compartments. The first compartment contains CH3, CH2 and OH. So that is one product, that is alcohol. The second compartment contains N2, N2, that is nitrogen gas. And from the third compartment we get H2O. So a primary amine can be converted to alcohol by reaction with nitrous acid produced inside the reaction mixture by reaction between sodium nitrite and HCl. Now a conversion reaction, that is CH3 CH2Cl plus silver nitrite, we get nitro ethane reduction using lithium aluminum hydride. NO2 is getting converted to NS2. Then sodium nitrate and HCl, the compound splits like this. HO connects here, NO like this, H2O, N2, CH2OH, so CH3, CH2OH. But there is easy method, that is this molecule on reaction with the sodium hydroxide, we get easily alcohol. But such steps are given by because questions may be asked to identify such and such compounds during the reaction with such and such reagents. Then such conversions are helpful. Now reaction with aryl sulfonyl chloride. Aryl sulfonyl chloride, it is, one example is para-toluene sulfonyl chloride. This is the compound, para-toluene sulfonyl chloride. It contains an S double bond O structure with the chlorine connected to the sulfur atom. Now, primary amine and a secondary amine can react with the para-toluene sulfonyl chloride to get solid derivatives. A primary amine will eliminate a molecule of HCl so that CH3NH gets connected to SO2, then benzene ring and CH3. So this is solid. And there is an NH bond. This NH bond can ionize to give H positive and N negative. This N negative can be resonance stabilized like this. The negative charge, that is downward, shifts into the position between nitrogen and sulfur to form a pi bond, and simultaneous shift of this pair of electron over oxygen atom we get a canonical structure. Then again this lone pair coming to a bond pair and this bond pair coming to a lone pair, we get another canonical structure, so that the conjugate base is stabilized by resonance, so its formation is easy, and its formation leads to the formation of H positive also. So the compound is acidic, and hence the para-toluene sulfonamide derivative obtained from primary amine is acidic and soluble in alkali. So it's a salt and can form a solution with the alkali. So it is soluble. Now secondary amine will form a sulfonamide derivative, but this derivative cannot get dissolved in alkali because there is no NH bond in the structure. So the reaction between a secondary amine and para-toluene sulfonyl chloride. See, for example, CS3 NH CS3, this is a secondary amine. There is an NH bond here, and that will react with the para-toluene sulfonyl chloride. The chlorine atom combines with the H from the NH bond, and we get a solid derivative. The solid derivative is due to the high molecular weight of this part of this para-toluene sulfonamide structure. SO2 there is no NH bond here, so this cannot be dissolved in alkali, so it will be remaining as a solid derivative, and a tertiary amine is not reactive towards this para-toluene sulfonamide because there is no possibility for elimination of HCl from a tertiary amine because there is no NH bond. So a tertiary amine is unreactive towards para-toluene sulfonamide. There is no NH bond. Coming to some conversions, that is ethanoic acid into methanamine. Ethanoic acid is CS3COOH, acetic acid. Methanamine is CS3NH2. Now here one carbon atom is lost. So we can guess the reaction of amines, amines derivatives, which will give amine as a product. So the preparation reaction of amines, a derivative of amine, that is an amide, on reaction with the sodium hypobromide can remove a molecule of carbon dioxide, so that the CO group of amide group is removed as molecule of carbon dioxide by reaction with the NaOBr, that is bromine and alkali NaOH, and this reaction is known as Hofmann degradation reaction, an important reaction. So first of all, the acid is reacted with ammonia to get an acid-base reaction. Ammonium acetate is formed, ammonium salt of the acid. This on strong heating can eliminate a molecule of water, and we get the amide. This on reaction with NaOBr, that is bromine and alkali, Hofmann degradation reaction, CO and O are removed as carbon dioxide. We get NaBr and CH3NH2. Now another method is the conversion of COOH first into COCl by reacting with the PCl5. The OH group of COOH is replaced by Cl. On reaction with ammonia, Cl is replaced by NH2, where one Cl and one H combine to remove HCl. Then again Hofmann degradation reaction, so that CO and O combine, removing carbon dioxide. and we get CH3NH2. Now to convert ethanoic acid to propanamine. Ethanoic acid is CH3COOH and propanamine is CH3CH2CH2NH2. Now first of all, we have to ascend this compound, so one carbon should be introduced. The COOH is reduced to CH2OH using lithium aluminum hydride. Then OH is replaced by Cl by reaction with the PCl5. Then Cl is replaced by Cn with potassium cyanide. We get CH3CH2Cn. Then this Cn group can be reduced using lithium aluminum hydride. 4 H atoms are taken, 4 hydride ions are taken from lithium aluminum hydride. So that we get CH2NH2 group. So 2 pi bonds are getting broken, 4 H atoms are equally getting connected to the carbon and nitrogen, and we get propanamine. Then hexanitrile into 1-aminopentane. Hexanitrile, when we say hexanitrile, the total number of carbon atoms in the molecule should be 6. So 1, 2, 3, 4, 5, 6. That is hexanitrile. But this may be also called 1, 2, 3, 4, 5 cyanide. So in cyanide the carbon atom is included and 5 carbon atoms are connected. So it is 1 cyanopentane, and that is also known as hexanitrile. So this may be called cyanopentane. Or pentane cyanide. This is to be converted into 1-aminopentane. So 1 carbon atom should be lost. Then for losing 1 carbon atom, in the case of preparation of amines, the reaction is Hofmann degradation reaction. CONS2 converted to CNS2 by removal of CO as a molecule of carbon dioxide. Now, first of all, this hexanitrile is subjected to partial hydrolysis. The cyanide group on hydrolysis first gives the amide group. Now let us see how this happens. OH negative attacks this carbon, simultaneous ionization to a negative. So a negative OH. Then one OH is absorbed from the medium, so that has to be returned. One HOH attacks this N negative. Now the lone pair of nitrogen forms a bond with the H, and simultaneous removal of OH as OH negative. So this becomes H positive, N negative, NH bond is formed, and C double bond NH is obtained. Now then, another OH takes part in the reaction. OH establishes bond with H positive formed by shift of this bond in between these two atoms, carbon and oxygen. To maintain the valency of carbon, this bond shifts over nitrogen so that nitrogen gets negative charge. So we get CONH negative. Now this OH has to be returned. So 1 HOH ionizes OH negative, H positive, and this negative nitrogen lone pair to H positive, we get CONH2. This is partial hydrolysis, the mechanism. And the hexanitrile is subjected to partial hydrolysis using alkali. The corresponding amide is formed, then Hofmann degradation reaction. CO is removed. So 1 carbon atom is removed as carbon dioxide by taking up oxygen from NaOBr. The product will be 1-aminopentane plus NaBr plus carbon dioxide. Then methanol to ethanoic acid. Again 1 carbon atom should be increased. Now this reaction is very simple. You react it to the PCl5, you get CH3Cl, then KCN, Cl is replaced by Cl, then hydrolysis, alkyl hydrolysis, CH3COH. Ethanamine to methanamine, that is a degradation reaction. One carbon atom is lost. Now ethanamine is CH3CH2NH2, it is to be converted to CH3NH2. CH3CH2NH2 is reacted with the nitrous acid, that is sodium nitrate Cl, to 78 Kelvin. Temperature is not necessary. The molecule splits into three parts. HONO, that is nitrous acid, also splits into three parts. N double bond part is split completely. HON part is also splitting. Then OH is getting connected to CH2. From this compartment, second compartment, we get N2 gas, and from third compartment we get H2O. So CH3 CH2OH. Then this is subjected to oxidation using alkyl MnO4. We get CH3 COOH. With ammonia we get ammonium acetate. On heating we get the amide, acetamide it is called. With the NaOBr, CO is removed, we get CH3NH2. So that is the sequence. Now again CH3COH may be reacted to PCl5 to get COCl. Then with ammonia CONH2, NaOBr, CH3NH2. So that is one possible method for conversion of ethanamine to methanamine. Ethanoic acid to propanoic acid, it is ascending of acid. We have seen this reaction earlier. First of all, a reaction with the lithium aluminum hydride, we get CH3 CH2OH. PCl5OH is replaced by Cl. Then KCN, Cl is replaced by Cn. Then hydrolysis, alkaline medium, we get Cn is converted to COOH. Then descending the acid, CH3CH2COH to CH3COH. CH3CH2COH plus PCl5, we get CH3CH2COCl, ammonia, CH3CH2CONH2, NaOBr, Hofmann degradation reaction, CH3CH2NH2. Nitrous acid reaction, we get CH3CH2OH, N2 and H2O. Alkaline MnO4 oxidation, CH3CH2OH is converted to CH3COOH, so that the primary alcoholic group is converted to carboxylic acid group. Methanamine into ethanamine, ascending the series. First of all, the methylamine is treated with the sodium nitrite HCl, that is reaction with nitrous acid, three compartments, CH3OH, N2 and H2O. So minus N2 minus H2O occurs here. Then reaction to PCl5, we get CH3Cl, then KCN, CH3Cl. Lithium aluminum hydride reduction, CH3, C triple bond, N is reduced to CH2, NH2. So we get ethylamine. The nitromethane into dimethylamine, that is CH3NO2, lithium aluminum hydride reduction, CH3NH2, then reaction with the CH3Cl, CH3NH, CH3, that is simple. Give the structures of ABC in the following reactions. CH3CH2I NaCN, that is Na is removed and Cn is getting connected, so compound A is CH3CH2Cn. Then alkaline hydrolysis, partial hydrolysis of cyanide gives amide, CnH2, so B is amide. Then NaOH plus Br2, that is NaOBr. So that Hofmann degradation reaction occurs, CO group is removed along with oxygen atom to produce carbon dioxide, so that CH3CH2 directly joins with NH2, so C is CH3CH2NH2. Now 9. CH3 COOH ammonia heating, we get CH3CONH2, that is amide. So ammonium acetate, salt of this acid, ammonium salt of the acid on strong heating eliminates water. producing the amide compound A is amide, NaBr, so CO is removed along with O as a molecule of carbon dioxide. CH3 and NS2 directly combines, we get methylamine. Compound B is methylamine, then sodium nitrite, HCl and HNO2 is the resulting product of the reaction between NaNO2 and HCl. So this molecule splits into three compartments, HO here, N here, and O here. CH3OH is formed. So CH3COOH can be converted to CH3OH, C by sequence, this sequence. So that is enough. Thank you.